So this is section 7.5, example 5. And here they're lifting a chain, and everybody should do a lifting a chain example. And so there's a chain all coiled up on the ground. That's not a snake, that's a chain. And what we want to do is lift this 20-foot chain to a height of 20 feet so that it's fully extended. So we're just going to grab a piece of it and start pulling it up, and it'll be sitting there on the ground. And at full extension, we're up here at 20 feet. And we're told that this 20-foot chain weighs 5 pounds per foot. Okay, so it's 5 pounds per foot. Oops, try that again. 5 pounds per foot. Okay, so the total weight of this thing, I guess, is 100 pounds. All right, so, how do we, try to add this up? Well, there may be various ways to do it. What comes to mind for me is to think about lifting a particular link, and so chain's nice, right? You got this chain that's all these links. I'm going to think about lifting a particular link and how far does it go, right? So the first link, now how much does it weigh? Well, I don't know. The first link, how long is that? Delta X or delta Y or something like that. Okay, that's how long that is. And so it weighs 5 times delta X. So that's the force there. And then how far am I going to raise that first link? I am going to raise that first link a total of 20 feet. Okay, so that first link is going to be work of 5 times 20 times delta X. Now, the second link is also of length delta X, and so it also weighs 5 times delta X. And so my second link, that is also 5 times delta X, but I am going to raise that just 20, right, 20 minus the top one, so delta X. Okay, so this is the total work here is 5 times that 20 minus delta X. And then what, 5 times 20 minus delta X, and then times the delta X. That's the second link. Third link. F, well, third link weighs the same, 5 delta X, but it only goes up 2 delta X, or 20 minus 2 delta X. And so the weight is 5 times 20 minus 2 delta X times delta X. And so on, the 10th link is F, the force is 5 times delta X, but the weight or the work is 5 times 20 minus 9 delta x, all times delta x. Well, you see what's happening is this thing in here, this minus delta x, that's actually my value of x. So in general, what I'm doing is I'm taking 5 times 20 minus, and that goes together to make some xi for the particular link, the ith link, and delta x. Okay, so I'm going to do this all the way from 0, x equals 0 to 20. So when I sum that up, I have 0 to 20. I have 5 and 20 minus x dx. So that is 5 and, oops, I know how to do that antiderivative. And so that's 5 times 20x minus x squared over 2. And that goes from 0 to 20. So this is equal to 5 times 20 times 20, so 20 squared, minus 20 squared over 2. And so that's 5 times 20 squared over 2, which is 200. And so we get 1,000 foot-pounds. Again, they're really big on foot-pounds for this chain. Now, if you read their example, they built it differently than I did. Okay, they did a different method of coming up with the weight of the chain at different stages. Okay, so what they did instead was they said the same 5 times delta x, or they use delta y. So they use that same force there, but they did their distance sort of backward from us. They said, let's see, because a typical section initially on the ground is raised up to a height of y, the increment of work is 5 delta y times y. So they did it as that link, you know, I had it as here's a link and it goes up this far, you know, how far is that? They called it y. I called it 20 minus y, but the symmetry gave us the same thing. Okay, so that it's, again, this is a modeling problem, right? It's a modeling problem. So one person may come up with a slightly different way to set up their coordinate system and so forth to determine what this is, but both got the same answer because both were perfectly good models. And you can kind of see that symmetry involved here because this went from 0 to 20 with the 20 minus x. Well, you know, going from 0 to 20 with just x ends up doing the same thing. Okay, you end up adding up the same numbers. Okay, so if you sort of think of this and step along, right, you had the 20 minus x, or you have x. When, you know, let's just step along at the integers, right? This, when x is 0, this is 20, and then it's 19, and then it's 18. And each of those, you know, I'm multiplying that 5 times delta x or delta y. Here, if x starts at 0, it's 0 and then it's 1 and so forth. But it goes up to then 18, 19, 20. This one goes down to 1 and 0. They are the same numbers times 5 delta x, or dx. These same numbers times 5 dx. So you see, the integral really is, it's just adding up a bunch of things. And in this case, whether I describe them that way or that way, they are the same things. Okay, so I think that's an important lesson to take with you in this modeling idea is, as long as you describe it correctly, your description could be different than somebody else's, but we do end up getting the same solution. So that is example 5, I think, right? Yes.